So it's an educational session. What was used, where they went, what they found, what differences they found between what they found and what was forecast, that sort of thing. You'll also hear some comments on communication, how they got the information and problems with communication. It isn't really isn't a bitch session, but there can be times when they get pretty pointed in complaining about what was sent and what was received. I really want to put a plug in for the Navigators Forum. Plan to attend. Lots of fun. So let's start back with today. If you go to the race site, bermudarace.com, you'll find right on the homepage resources. And one of the resources, when you dial down, lower right-hand corner there, is Gulfstream and weather. And under the Gulfstream and weather, there are some notes by me telling you again about the importance of learning a little bit yourself personally before you go out there, as well as a variety of resources, lower right-hand corner, that includes the tutorials over the past 15, 20 years and more, and a Gulfstream primer, which is a little write-up on what the Gulfstream is and what you might expect it to be today. Under that resources, there's a list of links. Now, mind you, this is my set of links. This is Bohlen's view of what's important for you. That doesn't mean that you have to use it, but so that you can personalize this in any way you want. But again, over the years, we found that this variety of sources of information really provides a good perspective on what information is available. We'll go through some of that right now. I can also send you this if some of you want that. I hope you noticed on that the lead slide there that bohlen@uconn.edu is a pretty simple email address, and I've been known to answer emails on some occasions. So let's start at the beginning. Whatever it is, we got to have some weather out there. So upper left-hand corner in the box is the National Weather Service site. And that is an incredible site. Our taxpayer dollar at work really provides a variety of information from the earliest introduction to what weather is and isn't to the variety of maps and services that are provided. This is broken down into two pieces you see up there, the National Weather Service site and the Ocean Prediction Center site. Both of them very valuable, and you should be very familiar with them, and you might think how you want to get that information on board. How do you compress those data to receive them on a sat phone, for example? Go system. The European Center is also there. There's some incredible maps, incredible views provided by the European Center. Very valuable. I want to call your attention to the lower right-hand corner box. It says NWS Archive Marine Weather Charts. Part of preparation for some fair number of navigators is to go back over conditions that occurred during past races. Now, after finishing 20 races out there, I can tell you that we have started under just about every condition known to man, and we have finished not quite as many, but a variety of conditions and experienced a variety of conditions down the track. So someone wrote the other day from Australia, first-year participant, asking about the average conditions. Generally it's a southwesterly wind. Well, sort of generally. There have been a lot of times when it's been anything but southwesterly. So it's sometimes, I think, for some number of people that want to be thorough in their preparation, useful to go back over some of the history of the race. And that archived set of weather charts is very valuable for that purpose. So if I clicked on the Ocean Prediction Center and the Atlantic offering, I might get a look at the surface map. This is the Atlantic Surface Analysis Map for a couple of days ago. You should be familiar with what all of this might mean to you on that track down to Bermuda. How to read a chart like this and what might be coming. Variety of fronts, those blue lines to the left. A variety of cold fronts, those blue lines with little sawtooths on the front end. There are some pieces of those fronts that are warm fronts, they have the little round figures in front of the lines. It looks like there's a pretty good sized low sitting out about 50 west or so. The question is how it might track and what it might mean to you. Now, I want to call attention to a couple of things here. This is a map that's produced by the folks at the Ocean Prediction Center by Mr. Shaw. This is a map based on some number of models, some number of satellite observations, and personal experience with the weather systems in the North Atlantic, what's likely to occur. So this is a very valuable asset for you, Mr. Shaw. And you can actually call, if you were looking at this and not confused by what you saw, you can actually call the Ocean Prediction Center, and if Shaw is still on duty, you can get to talk to him. It's important to realize that there is a human involvement in all this. Lots of model, but a lot of human as well. Now, this is surface conditions. I'd advise you also, while you're doing it, to take a look aloft. This is now the 500 millibar chart. This is the conditions at present, on the 26th of April or so, yesterday, at the 500 millibar surface, which is about 18,000 feet up. And this is really a topographic map. The numbers that you see on that are not high and low pressure. They're actually heights. So it's 5,500 meters above the surface. Got it? Now, the one line in all of that you want to pay particular attention to is the dark blue line in the middle running along. You see a darker blue line. That's the 5640 line, 5,640 meters up there. And that's generally recognized as a boundary of the storm tracks. So storms tend to track to the north of that line. Now, as the season progresses from winter to summer, the 5640 line migrates from further south in the vicinity of the Carolinas to north, maybe up off Newfoundland or even further north. You can take a look at this, and there's quite a little dip in it. Shows you that it's got themselves an upper level low sighted around 50 west. If you recall, when we looked at the surface chart a moment ago, there was a low in that vicinity of 50 west. So it's consistent with conditions aloft, which are the conditions that favor the normal westerly migration of weather systems. You know, we've got things going on in the south, in the northwest right now that are liable to be coming along this way normally. But every now and then there's a cutoff, what they call a cutoff low, a low that gets clear of the westerly migration. And they are real challenges to forecasting. So one of the best ways to get a sense of the longer term accuracy of the forecast that you're receiving today is to take a look at conditions aloft. If you happen to see one of these lows, like that 535 sitting somewhere up around 50 north, well clear of the 5640 line, you might wonder whether that low is cut off from the westerly migration and may in fact migrate to the west and complicate some of our forecasting. So cutoff low is very important to take a look at, the possibility of it. And the east-west possibility of east-west migration counter to the west-east migration also look at. Valuable information available on the 500 millibar chart. Okay, this is the 24-hour surface analysis now. You get an idea that that low we looked at in the vicinity of 50 is starting to migrate a little further out. Mind you now, we just changed scales. Before we were looking at the whole of the Atlantic. Here we're looking only at the Western Atlantic. You get an idea where Bermuda is. And this is a 24-hour forecast, and you can see this was the 26th or so forecast chart. And you can see there's that blue line with the raggedy teeth on it. That's the cold front that came through here last night. And you can see there was a little low that migrated along it, and it sort of tracked over the Delmarva area. Okay, call your attention to the location of Bermuda. We can also, that same set of data from the Ocean Prediction Center will give us some information on sea state. This is wind and waves for the Western Atlantic. Circle in the middle there with a little red circle around it. There's Bermuda. caution, every time you look at these guys, pay attention to the units. Some of these charts are in meters. Some of these charts are in feet. I can't tell you why they stick with meters on one all U.S. product and feet on the other, except perversity or something. But pay attention to the units. You get an idea. The green line shown up in the corner there, running along, is the north wall of the Gulf Stream. Sort of. We got an idea where it is. You're interested in looking at that. We'll talk a little bit more about that in a moment, because on occasion, that Gulf Stream, the presence of the Gulf Stream, can have significant effect on winds and waves. Now, the other guy to take a look at in the package, and it's in the list of links, is Bermuda weather. Down the bottom, the weather.bm, that's Bermuda weather. This is one of their products. This is the 12 Zulu forecast. And Bermuda sort of sits in the middle of all of that. Now, Bermuda is nice to have in hand, because another thing that we often tend to do is to compare different models. You know, we hear a lot about the Euro model here, and the US model is GFS. The Bermudians use a British model, which is yet different. There's a UK model, which is yet different than the two above. And so it's good to compare conditions, one model to another. And the other thing that Bermuda does, it provides 5 days of charts. This is the second day chart I think you're seeing. It is very valuable to us, again, because of the difference in models. But this one gives wind and sea state. If you look at that, a little hard to see, but sea's 9 to 15 feet, okay? And there's Bermuda sitting in the middle, and we might compare what the wind field looks like. Sorry, let's go back to here. So there's Bermuda, and it's showing something like 35 knots of wind, that arrow with 3 feathers and a half, 35 knots of wind from the north, with a 20-foot sea in the vicinity of Bermuda. And if we come down here and take a look, this guy is saying it's 25 knots, a little bit less, and 9 to 35. They cover quite a range there. At least they're both coming from the north. Okay, so it's well to compare models as you go along. Now, the next product we take a look at here, I just happen to pick this one off. This is a Predict Wind product. And this is for the European model sitting here. I think, unfortunately, hang on one second, I can drag this guy. Can't drag this, not allowing me to drag this. Oh, there we go. Thank you very much. Our pictures were hiding my script here. So this is the GFS model, and you folks have a variety of these products. I think I use Windy on occasion. I use ZY Grib on occasion. I use SailDocs on occasion. They're all GRIB products, gridded binary products. And the difference between the gridded binary product and that National Weather Service product is the absence of human evaluation. GFS and the Euro are strictly model products. But in general, they're pretty close to what's really going on. Now, here again is another way to compare your models. This one, as I say, is GFS, and I'm sitting on Bermuda down here, Monday the 25th. I have 22 knots of wind from the north. Again, we're looking pretty good about that northerly, 22. And if I go here, I've got the Euro model with 20 knots from 350, about the same. Okay, it's well to compare models. It's well to compare a model to the conditions you're experiencing so that you gain some confidence in the model. I spend a lot of time working with GFS. I think I have a good feeling for when it tends to under forecast conditions, estimate what the wind speeds are going to be or the sea states are going to be, and when it tends to overestimate. So you play with the models. You got to get to know your enemy, dance partner, whatever. Okay? Going at the weather.
Recording in progress.
going at the weather before you go out there, even if you have a consultant, is very important. So let's move on now to the Gulf Stream. The Gulf Stream. I guess you got a pretty good idea what it is. The oceanographer talks about the Gulf Stream as that portion of the North Atlantic gyre that proceeds from the vicinity of Cape Hatteras out to about 50 west. To the south of that, down along the East Coast U.S. to the Straits of Florida, is the Florida Current. But that's a distinction the oceanographers, meteorologists tend to make. Generally, we call the whole thing the Gulf Stream. It's a very interesting and dynamic Western Ocean boundary current. The Kuroshio looks the same way in the Pacific. It's a boundary between the cold water on the shelf and the warmer water in the Sargasso Sea. And it's energetic, as we'll see. This is a picture of water temperatures along a profile that ran from the Carolinas to Europe in the late spring. And you can see on this that as we move offshore from the Carolinas, that there's a fairly abrupt change in temperature. Okay? Water temperature is considered to be the single most useful indicator of stream location and temperature. You can feel it. You can sometimes see it. Can talk about that in a moment. But you can, by measuring temperatures as you go out there, and there's nothing wrong with liquid and glass thermometers. You know, everything doesn't have to be Brooks and Gatehouse. You can get a pretty good idea when you're in the stream or when you're in some of the stream features, bodies of water that are shed from the stream. Okay? If you take a look at this guy, a little more detail, the one just before, you can see as you go between about 16, 17 degrees. You see on the, sorry, let's go far left there. You got 10 degrees on the shelf, centigrade. That's about 50 degrees Fahrenheit. You move out across the shelf and the temperature progressively increases. You get around 16. There is an abrupt change in temperature from 16 to into the 20s, 24. And then you go along a little further to the east, heading towards Bermuda, and the temperature looks like it goes down a bit to 18. That body of red there that you're looking at is what I call the main body of the Gulf Stream, about 60 miles in width, a nice sharp change in temperature to the west, not quite as sharp a change in temperature to the east. Okay, and then you'll see a couple of bodies of water as you move down along the profile. It goes to 22.4, 20.2, 22.7. And that's other things between here and Bermuda, between the edge of the stream and Bermuda. Let's take a look at this. This is a, you'll probably see this again if you ever have me talking at you. This is a picture I show generally of the typical Gulf Stream structure. And if you look where it says Gulf Stream, you'll see that yellow band. That's the main body of the stream. That was that 60-mile body of water, okay, that had a fairly sharp temperature increase north edge and a less sharp change in temperature south edge. That's the main body of the stream. As you go along northeast away from Hatteras, typically the main body of the stream becomes more and more sinuous, like a whip. Okay, and the whip has ridges and troughs. They form meanders. But overall, the migration tends to be towards the northeast, towards England, towards 50 west. On occasion, those meanders will go to such an extreme that they form an oxbow and pinch off. And when they do, they form rings. To the north of the stream, the warm core ring shown in the slide. To the south, and we'll see more of this in a minute, to the south, the other form of the meander, you may get yourself a pinch off that brings you a body of cold water, a cold core ring. Warm core rings tend to rotate clockwise, cold core rings counterclockwise. Warm core rings tend to migrate to the west towards Hatteras and have a relatively short life because they bump into the shelf and the road and friction tends to break them down. In contrast, the cold core rings still migrating to the west, just like the warm core ring, but because of the water depths out there, those guys can hang around for a long time. The drift speeds of those guys are a few miles a day, typically, if they're clear of the stream influence, okay? So you're looking at this sort of a dynamic system, and we could spend half the day just talking about this. We said earlier that we're going to talk a little bit about these characteristics. This is a profile of current speeds measured across the stream. So if you notice down the bottom, I don't know if you can see my cursor, if I get one going here. If you can see that, on the left-hand side, it says 0 nautical miles, 20 nautical miles, 40 nautical, 60. So if you look at this, and the vertical scale, the Y scale, is centimeters per second. So as we move in across our 60-mile width of Gulf Stream, you'll see that currents generally increase from around 25 centimeters a second up to nearly 250 centimeters a second, with 50 centimeters a second equal to a knot. So here's 1 knot, 2 knots, okay, 3, 4, 5 knots. And it's remarkably constant max flows. 5 knots plus or minus a half a knot on that order. With maxima in about 30 miles from the edge where the temperature abruptly starts to increase, about 30 miles in. But the other thing to look at is that you have these 2 peaks. It's not a nice straight peak here. That is indicative of a filamentous structure. The flow is in a series of filaments. It's not a jet, simple jet. The moral of the story here is we're trying to go to Bermuda. Sometimes it's really not in your best interest strategically to go chasing, go looking for a 5-knot current boost to Bermuda. Be satisfied with 3 knots. You can do that pretty reliably coming across it. The filaments, you may have a hard time making the filaments. We have had over the years a number of times where those damn asymmetrical spinnakers wouldn't let us go far enough to the right, left to find the 5-knot current. Don't shoot the navigator if you don't find 5 knots. Be satisfied with 3. Okay? Now, in the old days, we used to go to the Navy, and this was about as good a plot as we could get. And they got this with aerial overflights that were brought out about every couple of days, and they were sent out to some few number of subscribers via subscription. I'm showing it to you because, and this site is listed in the links down on the bottom there, the NOAA JAG business. I'm showing it to you because it's black and white. And if you gain some confidence in it, and you have an idea that it's pretty accurate in terms of what you need or what you think you're going to be looking for strategically, it's low bandwidth. You can get it on a sat phone easier than some of these other guys. Now, if you don't like black and white of this product, you can go to the same site, a couple of other extensions on it, and get a color version of it. Both of them are interesting in showing a fair amount of meander in adjacent to the rum line, the black line. Looks like the main body of the stream, GSS, swings off to the southeast. So your track in this feature would favor going to the west of the line. Now, we can tell you again from having experienced something just like this, if the wind happens to be southeast, that can be very uncomfortable. It might be fast coming down to Bermuda, but it can produce a hell of a sea state, wind against the current. Also, in looking at this, remembering what I said about the oxbow features, when you see a meander that's this deep, and we'll see more of that in a moment, and you're seeing this now in April, and we still have a month and a half or so to go till the start, you might worry about it pinching off and just forming up a cold ring down there. Well, even if that happened, the favorite side of the cold ring, remembering that it's a counterclockwise feature, would be on the western side. So right now, the track to Bermuda, the favored track to Bermuda, looks to be well west of the rum line. Where I usually try to start is at the Rutgers site. I'm old school. I'm a hands-on. I like to put my hand in the water or my nose. I like to get off the nav station and get up on deck and look around. And the Rutgers site, the sea surface temperature down the bottom, IMCS, Coastal Ocean Observatory Lab, provides some very, very nice satellite images of the stream. So here's a couple of things. This is an IR image of sea surface temperature. And now, mind you, they mean it, sea surface temperature. The IR sensors are sensing skin temperature, just about, your hair's breadth down. You got to be careful with this. That nice dark red boundary, that's the main body of the stream, and you get an idea the temperatures are running in excess of 70 Fahrenheit right now. This was February, okay? And that there is a very nice meander, pretty orderly meander, one to the west of the rum line, trough to the west, and then crest about on the rum line to a trough further to the east. This, in theory, this whole feature would migrate very neatly to the northeast, as if it was a whip. I whip the line and the disturbance goes very orderly down the whip, okay? Now we go along a little bit further in time, and here we are in March, and it looks like that first lump that's on the rum line has migrated to the northeast. But what's going on in the vicinity of the rum line? There is a crest, if you will, well to the west, and then it's sort of sloping off down across the rum line northwest to southeast. Let's see how that progresses. Also, if you note, up by the blue, to the west, that is to the left of the rum line, in the vicinity of 40 there, you'll see what looks like a warm core ring, that blue blob in the middle there. Scream if you can see my cursor here. Can you see? That's the blue guy right there. Okay, I'm calling that a cold core ring. I'm looking down here, and I'm calling it a warm core ring. I'm looking down here, and I might see some cold core features as well. So there's a lot of information on this slide. March, and we expect all of this to migrate to the east. March 22nd, oh my goodness. Look, we had that that guy in the vicinity of the rum line has really deepened. We now have favored leg pointing directly at Bermuda. The track would be coming right down to Bermuda. Holy Christmas. That was quite a change in 20 days. Someone said earlier that things don't change too quickly out there when it comes to the Gulf Stream. It sometimes does. And it sometimes can even change over your 4 or 5 days to Bermuda. That's why getting to know your dance partner, how things change, what the rate of change is very important. And you're the only one that are going to get that by doing a little early study. By April now, March 22nd, here's April 22nd, that feature had deepened to a point where it looked like, on this slide, it looked like the feature was going to pinch off, leaving us with a cold core ring right adjacent to the rum line. Okay? Really neat, sitting down there. Now you got to be, so we'll look at that, another way to look at that in a moment. But for all the world, it looks right now like that feature is going to pinch off. But if you look carefully at the darkness of the color, there still could be the primary, it could still be a U, if you will, a deep meander, not yet pinched off. But for all the world, it looks like it's getting ready to pinch off on the 22nd of April. Oh, by the way, one thing I want to point at, parenthetical, call your attention to the white in these slides. That's cloud cover. And there's been a lot of cloud cover all the late winter, early spring. That's why it's important to get looking at some of these things early in the game. Okay, I want to call your attention to a couple of things. At the Rutgers site, you'll get two products. You got as in this April 23rd site, This is image, sorry. This is an instantaneous satellite image. Click, the camera took that picture. And it was able to do it, and we're able to use it because the cloud cover was to some extent broken up. You can see the white patches here and there. It's really nice, if possible, to use the instantaneous images. Problem is, it's generally not all that easy because there's a lot of cloud cover around. So they have 6 or 8 images a day, and what they'll do is they'll merge them together and produce a composite that gets rid of some of the cloud interference and gives you a pretty good image of what's going on at surface. That's the composite. But look, if I was using the instantaneous here, I might assume that the stream was contiguous across the run line, pretty contiguous. You'll note, unfortunately, a little bit of white sort of fuzzy right over our deep meander. If we look at the composite, it gives us a little bit better picture of what's going on. This is the 23rd now, day after the 22nd there that you just looked at. We've got something of a ring there and a little bit. So the composite gives us a better picture, but there are differences between the two, and you want to study that a little bit. Sometimes the composite produces artifacts that are the result of the compositing process. Little care, always useful. Now, the next product I want to show you quickly is the satellite altimetry. It says provides model currents based on satellite altimeter. They're measuring the height of the sea surface. If we had our string out there and our surveyors and we're riding along, you might be surprised, or maybe not surprised, to find that if you look at sea level surface heights relative to a gravity datum, that the surface heights in the Sargasso Sea are about 1 meter higher than the surface heights on our continental shelf. So some of you have always known that you're sailing uphill when you go to Bermuda, and it's true. But of course, the slope is pretty slight. You're talking about 1 meter in something over 100 kilometers, the width of the stream. So that's 1 part in 10 to the 5th, and there are probably floors in some of our antique houses that aren't that flat. Application requires care, but what's important is the model results allow analysis of Gulf Stream conditions during periods in which cloud cover prevents direct observation. And you've seen in some of those satellite images earlier that there are lots of times when there are clouds around. In addition, and for some of you it might be surprising, but you shouldn't be too surprised after looking at those satellite images, that the data from the altimeter also provides some indication of what's going on between the main body of the stream and Bermuda. Turns out Gulf Stream effects, people have put tracers in the stream and followed the tracers, little drifters, and some of those drifters end up in the vicinity of Bermuda. They're not all ending up in the vicinity of 50 West or England. They spin off and they end up down in Bermuda. So you expect some amount of that water doing the same thing. Comparison with the surface thermal data, such as the Rutgers imagery, the satellite imagery compared to the altimeter data, is recommended. Here's what it looked like a few days ago on the 25th. Again, black line is the run line, and you see clearly the altimeter would show you that we're not anywhere near here. We're talking about nearly 5 to 10 degrees of split in here, or sorry, 2 to 3 degrees split between the right and left of the meander. So it's got quite a ways to go yet, several hundred miles before it's going to pinch off. But it provides very clear indication that the favored track is to the west of the run line. Now, if you look down here, you'll also see, if we look in the area between, say, 38 north, where most of the stream is, and here we are 36 and further down when the depth, that's the bottom end of the meander, you can see just to the east of the run line, the green area is a cold ring rotating counterclockwise. And if you go further down, as you get to the vicinity of Bermuda, you'll see that there's something of an organized clockwise rotation, as in it's a warm core ring, but down in this neck of the woods, it wouldn't be classed as a warm core ring, an eddy feature. Actually, those counter-rotating features are not at all unusual and are often encountered as one approaches, gets down within a few hundred miles of Bermuda, and you wonder, where the hell did this counter current come from? You've run into one of these guys. So the altimetry-based model is a particularly useful product for taking a look at what might be going on in the track south of the main body of the stream. Okay, models. Everybody is playing with routing programs today. We all use, a lot of us use Expedition, but there are others. And a number of models are brought into that. Both weather, grid files are brought in, and current. The listing here are two sites. The NOAA site, which is usually the site that we go to get the global real-time ocean forecast system. That's one of the favorite models that's used in Expedition. But the U.S. Navy site is also provides a very interesting product. They're both using the model HICOM with some different input characteristics, so they're slightly different, and different ways to present them when we're talking about class presentations. Here's the global model image of the stream location. This is sort of sea surface temperature. And you can see the rum line, the black line again, or the, you know, the rum line. There's Newport and there's Bermuda, and there's a lot of black lines running across it. That it gives some fair representation of the meander, but I might look at this pretty carefully. Sometimes those meander dimensions are not well handled by the resolution of the model. You can get changes in flow direction over a few kilometers, whereas the model might be giving you quarter degree kind of things, you know, 15-mile resolution. So you want to be careful when you come to a feature like that. This model I would expect to be much better in and around the main body of the stream, when the main body of the stream is, quote, well behaved. It also gives you, this is the current profile now, what's sitting here, and it's held to interpret from looking at the picture. Here is the Navy product. This is sea surface temperatures, and you can get an idea that they have a little different representation of what the meander looks like. That's the big yellow loop there. So again, I might be a little bit suspicious of model product when we take a look at what both the altimetry and the satellite IR data was telling us. I'd be a little careful in how I interpreted that. And this, of course, is their current, and you can see if you look carefully, and I think unfortunately these guys don't give us a good pointer here, but this is their idea of where the currents associated with the meander go. Well to the west of the rum line, and nowhere near as orderly in structure as what we saw from the altimetry or the IR, Rutgers IR data. So I'd be careful in the application of these models. Finally, it's really important to remember that the Gulf Stream, with its high water temperatures, often serves as a weather breeder. Why? That's your homework assignment. Why? High water temperatures favor evaporation and upward migration of warm air. And the combination, as it runs into colder air aloft, often favors the formation of a situation and pressure gradients that favor low pressure systems. The famous guy is when we get ourselves a cold front coming down across the stream. And we encountered this a few years back, coming back from Bermuda. Cold air mass. Cold air is more dense than warm air. The cold air is pushing the warm air that's sitting out there over the Sargasso Sea aloft. You push air aloft, you tend to generate systems that favor low pressure. The air is going away from you, up the chimneys. and dispersion aloft. So here it comes, and it runs into the Gulf Stream area. And the Gulf Stream area is already, the air is rising. And very often as you come down to the stream, you're going to see a streak of clouds. Your first visual sighting of the stream in general is a streak of clouds. The clouds produced by the warm air rising and condensing, forming clouds. Okay? We're going to accelerate that rate of upward migration, convection. Okay? And when you do, you generate low pressure systems that produce, quote, some interesting weather conditions. Sometimes the extreme, we've often seen plenty of thunderstorms down there. Hardly ever seen a waterspout, but there are conditions that favor them. We're seeing more tornadic activity, if you watch the evening weather news these days, than we usually have seen, okay, over our lifetime. But we can show you some weather maps, but this one gives you a pretty good idea of the kind of things that go on. Here comes a cold front down across the stream. Bermuda's sitting out there in the middle. The front is not yet down to Bermuda. And as it comes, it rapidly, as they call it, rapidly intensifies. It's a meteorological bomb, rapidly intensifying system. And this guy is, as they say, as I said here, it should be fairly clear where we don't want to be. So if you see something like this coming down across the stream, you may want to delay your departure from Bermuda. Or if you see it coming down and before you get to the stream, you may want to do a few turns before you get to the stream. Or really get yourself ready for some fairly intense weather to the point where this is developing hurricane force. It's not a tropical system, but it's got wind speeds up to hurricane force. Okay? So that's it for the moment. The moral of the story, both from the Gulf Stream and the weather, is you want to start taking a look at some of these characteristics using the resources that are being provided to you as early as possible. Start now. It's not too early. That series of slides I took off yesterday just gives you some idea of how much white is out over the stream. And this is pretty good compared to what we saw from most of the period February to now. Okay? Not too early to start. A month or two away from the start is not too early at all, particularly if you want to get back and do some archival stuff, bringing up those systems and plugging them into Expedition and running some scenarios and seeing what that might mean in terms of your sales, in terms of your strategy, what you're carrying for what, maybe even the crew, and preparation. Preparation is everything. Someone wrote down somewhere that races are lost on the water. That implied from the statement that the place to win a race is before the race. You prepare, you get your crew ready, you got the boat ready, and you got your knowledge ready, your personal knowledge ready. Don't rely on consultants. They're good to have as a consultant, but you're going to be out there. And the more that you know about what's going on, the better. Thanks very much.
Frank, thank you. We've got a few questions from the audience, as you might expect.
Good.
And one of them relates to the current models you were just showing. I'm not sure if you want to answer this. How do you best determine which current model is more correct when you're looking at them?
Well, I think the current models are much like the weather. You have to take a look at how well the model compares to the reality. And the reality that we have to work with are the IR images. So what I'll do is I'll set up, and I think you can do it based on just that one slide I showed you of the stream structure, get an idea what the stream currents are looking like. What do I expect to see in currents for this time? And then, now one of the things, for example, if I put a lot of reliance on the altimetry, but it's qualitative reliance. I care more about where the features are than what currents are associated with the features. I got an idea what the currents are associated with the features. 2 to 3 knots in the rings, as I said, 5 max in the current. What the altimetry gives me is a good idea where I'm going to find the rings and where I might find a severe meandering to an oxbow in the main body of the stream. So a comparison between the the IR data, what the stream is looking like. You can get an idea how you're going to be set. And then you run the model with your boat in there and get an idea of what it's telling you in terms of set and compare the two. And then you try it with a different model. Do the same thing.
Okay, we have a couple more stream-related questions, then a couple forecasting questions. We'll take the streams first. What is the average speed across the stream? Your chart looks like 2 to 2.5 knots over the 60 miles. Is that about right? I'm
Average?
That's the question.
If we come, as that picture that I showed you would tell you that as you proceed, now we're in the Gulf Stream, we're to the northeast of Hatteras. The picture is going to be different if I went across to the Bahamas from Florida. But if I started in northeast of Hatteras and I went across the stream, I'm going to see at times currents as much as 5 knots. But most of the time, I'm going to see something on the order of 3 knots. So this is not, as I say, a jet. So speaking to me about average current is a little meaningless. It tends to vary, and particularly on your boat. Now, you can sit here, I can figure out if we're asking how much water tends to carry how much heat to the North Pole, an average current might mean something. But in terms of set and drift, how the boat is going to be affected. The boat is affected at this moment by 3 knots, at that moment by next moment by 3.5 knots, up to 5 knots, and then so forth across. The average of all of that might be on the order of 3 knots a set. Complicated.
Yeah, I heard you say look for 3 from your navigator.
Yeah, I think that's if you're figuring that I'm going to get in that leg going down along the rum line. Let's say that leg stays there, and we get in that. And for one reason or other, as I said, because of the asim or whatever, the wind speed, the wind direction is keeping me from really diving off to the right. 3 knots is a very nice set for the 60 miles for most of us. Now, on an 18-knot flyer, it may not mean much, but the stream doesn't mean much anyway.
All right, here's a broad question. With everything we read about climate change, how much change has there been in the velocity and path of the Gulf Stream?
Oh, not much in velocity structure. We just got through that. But there's some very interesting things going on. I told you that if I was teaching a class 10 years ago, I would tell you about, and I have slides to show you, that the meander patterns are migrating to the northeast at a very, very regular speed. So if I see a meander forming up to the west towards Hatteras of the rum line, I used to be able to tell when it might move over the rum line and keep on heading towards England, meaning that I could sort of figure my course and speed with that kind of modeling estimation. Today, and this today now is at least 5 races, say 10 years. One of the things we've been seeing is just what we saw this year. The depth of that meander, the speed with which that meander formed a very deep meander is historically unusual. And so what we've seen, whether it's climate change related, and there is some indication of change in the mass transport, the amount of water moving through the Florida Straits. That's sort of the strength of the hose flow. And as we leaves Hatteras, that's the jet going offshore. There's some indication of a decrease in that flow, which may very well affect the meander patterns. And the other end of that is the meander pattern we're looking at right now favors the formation of a cold core ring. The meander patterns could just as easily be forming and favoring warm core rings. And the number of the warm core rings that are coming up on the shelf and affecting the rate of change in temperature in the Gulf of Maine has been noticeably higher over the last 5 to 8 years.
So we'll keep watching.
Yep.
A question came up earlier that we answered in the chat, but we wanted to ask you to clarify it. The question was, we can't use predict wind during the race. only before the race, correct? And we referred to our competitor bulletin number 9, which addressed the routing of this. Can you pick that up?
Yeah, you can use predict wind for wind. What they're telling you they want you to do is to use it for routing. They want you to do the routing with the products, and that's the difference.
So simple as that.
Yeah, I think so.
Okay. We got a few more questions. Actually, several more have come in. So let's see how we can go here. What model does Bermuda use to feed their machine/man synoptic charts?
It's the UK model. I could send you the name of it. I don't have it off at my fingertips here.
Okay.
Send me a question. Send me the email at Bohlen. I'll send you the model. You know, that's one thing that we want to go back at for a second. The different models and the resolution, spatial resolution of the models. Spatial resolution refers to the grid size of the model. Okay, so they do some calculations and they give you an indication of the weather over a certain area. And that area, if you looked at the predict wind, was something like 50 kilometers. Now the products from GFS, the National Weather Service, that come out are 25 kilometer spots. And the European model is a little bit smaller, but on that order. A lot can happen in the weather along the edge of the stream when we're talking about 20 kilometers, 25 kilometers, 50 kilometers. You notice that temperature change occurred over a few miles. So you got to be careful when we look at those synoptic, the big area charts, that some things may not be going on quite the way you expect them to go on because of the resolution of the model.
Okay, will you say more about how frequently you get updated versions of these different data while at sea? Which ones do you just look at before the race, and which do you get on the fly to update your strategy?
I'm not sure what you mean by the data. If you're looking at the weather, we're looking at it all the time. Even though generally not too much changes in 4 days, although the 2016 race gets live to that. That was an interesting race. If you remember, there's some number of people dropping out because of what was forecast to be extreme conditions in the vicinity of the stream, and that didn't happen. I can tell you, leaving from Newport, and we did on a Swan 46. We were looking at the weather 4 times a day. The U.S. Service provides weather 4 times a day. The rest of it being, for the most time, me on boats that have nothing more than a sat phone, so they're bandwidth limited. Any of the color pictures are off. I don't get them. So the altimetry data I look at when I leave, as late as I can, and hope that things haven't changed too much. And generally, despite of some of the things I said, generally the stream doesn't change too much in that time. The one thing about the altimetry is there is a 2-day delay in that. It takes them that long to process it. So on occasion, and on one occasion I can remember painfully, the cold core ring in 2 days had migrated enough, there was enough difference between what was forecast in the altimetry and what we found as we came down there to cause consternation. So you got to take a few things with some grain of salt. But so anything color is generally off limits.
Okay, here's another one. Can you explain the relationship between the SST gradient, or sea height, and current velocity? How are the models going from this measured data to velocity? Is there any rule of thumb we can apply the same way we might look at atmospheric pressure gradient to estimate wind velocity?
Yeah, there is. Most of the models, or some number of them, provide you with what they call a geostrophic, an Earth-turned nomogram, and it's doing exactly that. It's looking at temperature, which is pressure, to estimate currents. Problem is that the currents that we have out there are really in part caused by water temperature and salinity issues, and in part caused by tides. There's a tidal component. We term them baroclinic, that's inclination of equal pressure surfaces, and barotropic, and that's inclination of different mass surfaces. The tide picks up the water en masse and moves it around. So when you get out there in the vicinity of the stream, and then when you have a wind effect on top of all of that, it's very often difficult to have a simple nomogram. But you will see some of the plots, like the Navy plot, used to have a nomogram on it, a geostrophic nomogram.
You got energy for a couple more, Frank?
I got the time.
We're running past our hour, but I can tell there's a lot of interest.
Yeah.
What could one expect in current speed in the cold rings? If the main current speed is 3 knots, would a cold ring be faster, slower, the same?
The cold ring currents are on the order, max currents are on the order of 3 knots. And they're separate features. You realize they don't carry the current. If they encapsulated, if you will, some amount of 5-knot current from the stream and form the ring, it doesn't work that way. You don't get 5 knots out there. What's driving the current is the temperature, the pressure gradients in the ring, and those generally are on the order of 3 knots. They can be and the other thing about the cold core ring, you got to remember, it's cold water, relatively cold water, which tends to be more dense, which tends to favor some amount of sinking of the cold, meaning that very often a cold ring could be covered by a skin layer of warm water to the south of the stream. And the satellite imagery is only looking at that skin temperature. That's why the altimetry data are so important to you, because they'll show you where the ring is independent of what the temperature. It may be hidden under the temperature, but it'll show up in the heights.
All right. Maybe you'll know the answer to this. I don't. Can you comment on the Mitch Rule?
Oh, yeah, I don't know. I'd have to guess. I don't think I've ever heard of a Mitch Rule, but I think you're thinking about Finisterre and their winds and why they always hugged off to the west of the rum line. If that's what it is, and you might ask him interrogative, if that's what it is, the best information they had back then in the 60s, that was actually in the 50s, this last wind was in the 60s, that the best information they got from Woods Hole. Woods Hole did the briefings before the Bermuda Race, and that was on the basis of a shipboard survey taken a few weeks before that. And it wasn't really until the late 50s, into the 60s, that they had a sense of the number of rings, the instabilities in the stream. So with that in mind, they were dealing with a river that went from Florida to England, and you got pushed, when you got in it, you got pushed to the northeast, end of story, I stay to the west of the rum line.
All right, if you're describing to somebody who hasn't been there yet, the typical cloud features seen over the stream and the rings, how would you describe them? I think you said streets of clouds earlier. Also, how do you combine what you see in the sky with the other information you've got to fine-tune your course?
Depends how good an observer you are, but that's the answer to the last one. But it's generally a cumulus form, alto, not necessarily a great nimbus cloud. They're generally fairly discrete, so there's lines of cumulus clouds. Of course, it depends a lot on whether there's warm front, cold fronts around, but in general, you'll see cumulus cloud. What do you do with it? Well, you're now a little bit more alert. You're keeping an eye on water temperatures. You're keeping an eye on set and drift. how the compass compares to the course over the ground. It just wakes you up. Now, if you see, there's another one I can tell you. We came down into one of these lines one day, and there was a certain lady, known to some fair number of folks around here, who was actually knitting on the housetop when what looked to be a fairly benign feature close to what we thought was the horizon yielded a squall wind that blew a Genoa through a spreader and discombobulated the folks on deck. So when you're sailing down into a cloud bank, be careful. You're generally alert what's going on.
Okay. This is another question on warm and cold rings. Can you talk about velocity profile you did of a warm as well as a cold core ring? I think you did, but where would the optimal entry and exit location be, for example?
Well, I'm not sure I can answer the optimal. It's you got an idea that you got this donut rotating, both of them, on the order of, with max currents on the order of 2 to 3 knots. And the max current is going to be found some distance in from the edge. It's not going to be at the edge. It's going to be some distance in from the edge, with all of it governed by the temperature gradients that are present around the ring. So you got this donut rotating, one rotating one way, one rotating the other way. If you got your choice and you're heading for Bermuda, and I got you with me? I got a spot on the table that's Bermuda, and I got this donut sitting up here on the table. The optimum location to enter is, if I'm going in a cold core ring, it might be the northwest corner that I can ride down the west side as it jets me down to Bermuda. You certainly don't want to go into the northeast corner going to Bermuda on my donut sitting on the table here, because you're going to run into a current that's going to the northwest. So you're running into a counter current. And the warm core ring is just the opposite. You go into the northeast corner to carry the flow that's bringing you down towards Bermuda. So the answer is, it depends.
There you go. There are a number of further follow-ups on predict wind, and it may be that we should answer these in writing subsequently, but let me just give you the flavor of a couple of them so you can decide whether we should have the committee answer it in writing to make sure we don't lead anybody astray, or if it's pretty clear, you can go for it. If I use predict wind to do the routing pre-race before the race start, can I update the wind only as I go along? Someone else says, did I understand you to say that one could not use the routing on predict wind or on expedition once the race has started?
No to the last one, sorry. It's my understanding, and you're quoting Bohlen now, and I can't speak. I'm not speaking for the entire race committee, but it's my understanding that the philosophy behind the whole thing is they want as much of the routing as possible to be done by you on board, as opposed to the routing done by predict wind, and then the result of that fed back to you on board. Expedition is your program. You've set it up. You have it with you. You are hopefully downloading some amount of wind, updating that, maybe updating some amount of the Gulf Stream current data, the real-time ocean forecast system, for example, and interpreting all of that, what it means to you and your boat. You have your polars and the rest in there. So expedition can be used on board. It's you doing it. As I understand the product, predict wind is doing that for you and sending you the product.
So I'm going to gonna suggest that we follow up in writing with this webinar is going to be most of it's been recorded. It'll be posted to the website, and we'll add a clarification there, particularly if it turns out that we've said something that's
right. I mean, we're speaking of, I'm sorry, John, we're speaking of Predict, Win, and Expedition, but as I said, there's a fair number of other routing programs. Some of us have the Time Zero, and the old Nobletech stuff.
Yep.
Sort of thing. So if you have the product on board, use it.
Okay, this will be. I think maybe this is time to wrap up, Frank, to say thank you, and
thank you.
We will post the recording once it's converted. Believe we started the recording late, but we have at least one offer of a recording to splice in, so we may be able to get most of it posted tomorrow at some point, and it'll be on the website at bermudarace.com. And there was a question about the resources. I saw your resources again for the Gulf Stream. You follow the navigation to resources for sailors, and it's one of the links on that page.
Yes, if there are any questions on that, I hope everybody believes what I said. Bohlen@uconn.edu will get a response.
Great. Well, thank you very much, and thanks everyone for all the questions. Follow up with Frank if we didn't get to your question. Thanks all. Hope you have a good evening, and we'll be ending the session now. Thank you.
Thanks, John. Thanks, Katie.